audible at the back? Thank you. So hi everyone, it's great to be back. Pycon is always an amazing experience to share insights and discuss about code. So I'd like to talk about design patterns in Django. Django programmers in general do not talk much about object-oriented programming or design patterns, not that much as maybe Rails or Java community. I think I see it as a deficiency, and I think we could talk more about it, and this talk is just trying to trigger that kind of conversation. Hi, my name is Arun Ravindran. I blog and I have screencasts posted at arunrocks.com. I recently open sourced a project called Edge, which is a project template for Django. What you see down there is a shameless self-promotion. I'm actually writing a book about Django design patterns and best practices. It will cover almost 40 to 50 design patterns and best practices covering Django 1.7. And it will be published by PacketPub by the end of this year. So here's an outline of what we're going to talk about or cover in the next 30 minutes. I'm going to talk about why we need to talk about design patterns, what kind of design pattern we use in Django, especially the broad design pattern, that the MVC design pattern, which is a common question which people have. We're going to cover about 9 common design patterns in Django. There's going to be a lot of code. These slides are going to be uploaded online, especially on the talk page, so don't worry about that. And we are going to discuss about the code as well, so we'll have fun. So this definition of design patterns might be familiar to some of us. Design patterns is basically a reusable solution that can be applied based on the context for a software problem. Interestingly, it's not starting with software that design patterns actually started with, right? So around in 1977, Christopher Wolfgang Alexander collaborated with other architects to write a book called A Pattern Language, Towns, Buildings and Construction. So he's an architect in the traditional sense, not the software sense. And he wrote a book which covers about 253 different patterns. And when I say patterns, he's actually talking about a certain problem which commonly occurs in the field of architecture and a solution in terms of what is a practical solution to that. So this book was a little bit controversial because in his opinion, users should be the best judge about what a good solution is, not an architect. So this practice or this idea has slowly creeped onto the software world as well. And most of us are familiar with the Gang of Four book, which is where design patterns really became popular in the world of software architecture. So that is not the only book about design patterns. There have been several other books about design patterns, such as Martin Fowler's book on architecture, enterprise architecture patterns, refactoring into patterns, and several other books which are considered as pattern repositories. They contain a lot of patterns in the form of easily reusable collections. So some of us might be wondering, when we are talking about web application development, there are hundreds of things to worry about, especially when we are talking about a production application, right? There's database design, there's web design, there is sharding, there is caching, thousands of concerns. And now here's a guy who's telling that you should also think about design, and you really don't have time for the most elegant design, right? I mean, we are just trying to ship code at the end of the day, and users don't look under the hood. They don't care about how it's implemented, but who cares? We care, right? We as programmers really worry about what the best solution is. So some of us have this deep inner desire to create elegant and beautiful code. We actually want to see solutions which are most attractive or most elegant in terms of how it's implemented, how it's reusable, and how it can be maintained. Again, if you learn one design pattern, you can apply it to various different projects. They are repeatable solutions. It gives us a common language to talk about. If somebody says, hey, I did this implementation using publish subscribe pattern, he actually saved 15 minutes of explanation. He doesn't have to tell, okay, there is this sender and there are multiple receivers listening to that, and you have to send messages to all that. All that conversation is eliminated, and the person at the other end immediately understands, oh, publish subscribe pattern. I understand what you're talking about. Reduces trial and error. This is very important. So some of us actually obsess over, what is the best solution, or, whether solution A is better than solution B. We go through Stack Overflow, we go ask our friends, we ask IRC, hey, you know what, it actually works, but I'm not really sure whether this is the right way to do it, or am I doing this right, kind of questions. And most importantly, it formalizes best practices. So if you know the Django design philosophy, a lot of practices which are imbibed into it have been articulated in the documentation. They actually say, write dry code, right? Do not repeat yourself. Always follow separation of concerns. Use solid object-oriented principles. So this is not, the last one is actually not mentioned, but single responsibility principle, list cost substitution principle, all these concepts are very well known to people who practice object-oriented programming, but it's actually not well articulated in the Django community, but it's actually used, as we'll soon see, inside Django. So now, here's a common refrain that we'll hear among Python programmers. They say, design patterns, hey, Python is an object-oriented language and a scripting language. We don't really need to use design patterns, right? But that's not really true. As you can see in the slide, there are a lot of design patterns that's used in the implementation of Django itself. Now, before we talk about this, how many of you in the audience actually know what an abstract factory pattern is? Just raise your hands. Have you used it? Okay. How many of you know a singleton pattern? Great. So sorry to disappoint you, singleton pattern is now considered an anti-pattern. So, and again, abstract factory pattern is not really required in Python, because you can, it was actually designed in a different language. It was designed for C++, which actually uses static typing, strict type checking. But if you use a function instead of a class in Python, you can actually do the same thing for creation of objects and thereby create an abstract factory. So what I'm trying to say is that when you just blindly follow the Gang of Four patterns book, and try to implement all those extra classes and interfaces and everything ditto or verbatim in Python, you'll hear a lot of ducks quacking in the background. That's actually reminding you that Python is a duck typing language. You don't have to jump all those hoops. You just don't have to worry about types at all. So what I'm trying to say here is Gang of Four patterns are not very widely used in Django implementation. You can see that there is the observer pattern, which actually is used for implementing signals. So there is one sender and there are multiple receivers. There is something called template method pattern. So that's actually used in class-based generic views. You can override various parts of the implementation of a generic view using the template pattern. But I found that Martin Fowler, whose patterns are more towards the architecture side of things rather than the design side of things, his patterns are much more widely used. The active record pattern, which is actually documented as the Python, the Django implementation for models, encapsulates database access as well as business logic inside the models. We also see the identity field pattern, which is quite straightforward, which is basically storing the ID. We also see the template view, which is nothing but Django templates. So as you can see, the Django implementation or reading the source code of Django helps you understand various patterns which are used. Of course, if you have that background of what context we are talking about, you'll immediately recognize this is the pattern we are using here. This is a very common question I come across. Many people ask me this, does Django follow the MVC pattern, or hey, the developers of Django say that we are not using MVC, we are using something called MTV. So the reason behind this is MVC is easily misunderstood, right? MVC actually, if you look at the history of MVC, it actually comes from Smalltalk, which used MVC for its GUI, graphical user interface, and that's where all these concepts of controllers and models and views come from, which is completely different in the world of web application development, right? So we don't have mouse and keyboard and all those kind of things, but we have something called a request response cycle, which is happening inside a web application. So the creators of Django felt that the entire Django application or the framework can be divided into models, templates, and views. So what we are trying to say here is MVC is nothing but separation of concerns implemented. Now MTV is also a case of separation of concerns implemented. We have, if you are talking about one-to-one correspondence between models, views, and controllers, you will see that models are nothing but Django models, views are nothing but Django templates, and control is probably the rest of the entire framework itself, which actually works as a controller which controls what the user is trying to send in the form of a request all the way back to the response. So according to me, the answer is both yes and no. It's kind of an MVC variant, and people should not obsess too much over it because we are actually talking about separation of concerns here. So now let's get to the real meat of this presentation, which is design patterns. We're going to talk about 3 model design patterns here. Some of these are very familiar to you folks, so I'd be interested in hearing various other implementations, but I've gone through several implementations to find out which is the most optimal or which is the most appealing in terms of elegant code. The first one we talk about is user profiles. So almost all of us here have tried to create some user model or the other. Unfortunately, all of us think that since Django's custom user model was released in, I believe, Django 1.6, all we have to do is, just extend the custom user model, add, the user preferences, their favorite color to their pet's name, to their, relationship status, everything. I've seen this quite a lot, and which is exactly what the documentation tells us not to do, right? The user model is just for authentication and nothing else. So when you're actually extending it or creating a custom user model, it should be for a very good reason. It should be because you don't have the defaults which are mentioned in the authentication. For example, you would like to use email as the user, instead of the username as the login for that particular user. So in such cases, we actually should use a custom user model. And some people, this problem or this pattern has been seen ever since the first version of Django was released. So there have been a lot of solutions online, and this is another problem with design patterns. So if you ask what is the right way to do X in Django, the solution depends on what version you are using. So immediately you'll get the question, okay, which version of Django are you using? Are you using 1.6 or 1.7 or the about to be released 1.8? So the answer actually varies based on which version of Django you're using. And there have been various solutions like concrete inheritance. So I don't know why people still use concrete inheritance or why it's still there in the documentation. For me, it's like, an Indian KFC with veg burger. Nobody knows why it's there in the menu, but it's there in the menu, So concrete inheritance is not really a good solution because it involves a lot of extra database lookups, and at the end of the day, you'll probably replace it anyway. So what is the recommended solution? The recommended solution is very simple. The documentation tells you what to do. Just create a user profile model with a one-to-one mapping with your user model. But that's all the documentation tells you. It doesn't tell you how to implement it or what are the problems you'll face in or what are the steps you'll face in actually implementing it. That's what we're going to talk about right now. So if you talk in terms of steps, the most obvious step is to create a user profile model which has a one-to-one correspondence with your user model. Now again, notice that we are using the auth user model setting from the settings. This is because the custom user model was introduced, and we're also going to say primary key equals true. This is strictly not required, but this prevents a lot of concurrency issues when you're using the PostgreSQL database. It's a harmless thing. I would recommend to put it in there. The next thing is, how do you ensure that our user profile model, of course the user profile model should be having all those extra stuff that you want to put in your users, like what is their favorite color or what is their profile information, address, etc. Next thing is to ensure that there is always a user profile created whenever a user is added or created. So the easiest way to do this is using signals. So just handle the post save signal here. As you can see, that should be a decorator. As you can see, there is a created flag which is passed to that particular signal handler. So if it is not created, then obviously there should be something already there. But if it is already, if it is being created, make sure that there is a profile model being created corresponding to that user. So if you notice this code, you'll notice that I'm not actually passing any extra arguments while creating that. So this is a very typical use case. So what I would say is that if you are actually creating this profile model, make sure that the profile model has nullable fields or default values. So this is very important. So most probably your profile will be passed just one user as a parameter, as a keyword argument, and all the remaining values will have to be some kind of default values or nullable values. Next, we are going to use a new feature in Django 1.7, which is called app initialization refactor. So every time a signal was used in Django, most people were not sure where to put that signal handling code. Some people used to say put it in the init file, some people used to say put it in your models, put it anywhere, we don't care. But now we have a real place to put it. That's called the config. Now all you have to do when you create an app is make sure that there is an init.py which specifies where the app config is. Once you have this app config, you generally call it apps.py. You define this app config, and inside this app config you will be given an opportunity to initialize whatever initialization code you need for that particular app. You can use the ready function and override that as a method. So I would say that I would recommend putting your signal handling code over here. Now there are a couple of optional stuff that you can make the life easier for your admin. For example, many people prefer to change their default admin editing code for the context mixin to populate the context and simply find out what template it is and renders that template. It becomes so easy because it is leveraging. Now, what is Mixin actually? Mixin is actually multiple inheritance, which is not found in many other languages, right? Python is unique in that sense that we have multiple inheritance. But many people ask this question: isn't there an adage or a saying that composition should be favored in terms of inheritance? I would say it is true, but actually you get the best of both worlds, because even though mixins are technically inheritance, you actually are able to use the features of composition, because if you look at template view, it's a derived class. It's actually a type of view, but it's also getting all the compositional advantages of aggregating all the methods and attributes into one single class. So it's actually the crisp example of how we can compose as well as inherit without having the disadvantages of both. Now, the reason I explain more about this is because it's not just in views. Django uses mixins also in models, forms, what have you not. So it's kind of like a must-go kind of an implementation right now. Coming back to context enhancer pattern, so several views, like I said, need to use the same query set over and over again, or some variable which has to be defined in various queries in various templates, just because you are going to reuse that same thing again and again. The recommended view of you doing this is overriding the get context data, because context mixin is used for most of the generic views, but you can't do this everywhere, right? You can't copy paste it everywhere. It's not just dry enough. What I would recommend is to use a view mixin. Now, view mixin actually does the same thing, but it can be inherited. So you can use the get context data. If you have a public feed variable which needs to be there in every view, just define it. Just call the superclass first and just define that particular variable and return that context. Now, all you have to do is whichever view you need this particular feed, you just have to derive feed mixin, add that to your base classes. So the way you MRO or method resolution order is the most confusing bit of using a mixin, but it's actually quite easy. Just include your mixin at the beginning and just put your base class at the end, and you're all set. So people who are fans of Monty Python might recognize this. There are people who actually create websites which, this is a very common requirement in which there are views which should be public. There are views which should be accessible for particular users, and unlike the knight, you need to let people give access, right? So things have changed in the world of Django when it comes to class-based views. The previous implementation was to use a decorator. Most of us are familiar with this decorator, login required. You just use that for a function-based view. You just wrap the entire function in a decorator. But this is not very nuanced, right? What happens in a decorator is it takes a function, it just wraps that function inside, and it's able to do something before a function is called and after a function is called. It's not able to do anything in between. But it's a little more nuanced when it comes to mixins. You can actually use something called a method decorator, which actually is invoked for a particular method. And in the case of login required, this is the equivalent code for class-based views. You can actually wrap dispatch method for method-based decorator, and all you have to do is derive from this particular thing. So this is all these kind of design patterns are incorporated in a package called Django braces. Many of us are familiar with this, and Django braces actually has a built-in login required mixin, so you don't have to reinvent the wheel every time. Now we come to very simple patterns which are common in templates but surprisingly less used. So some of us who are coming from the PHP world or any other templating language are familiar with how we actually use reuse commonly required pieces of a website when it comes to HTML, right? For example, the navigation menu, the sidebar, the footer, all these things are commonly, they are repeated across pages. In other templating language, what we typically do is called the include syntax, in which we actually include pieces of code which are reused across. But Django uses a slightly different model, which is similar to the way you inherit from classes. You actually form a base class or a base template, from which other templates are derived, and you can actually do this to the nth level, right? You can actually think of certain pages in a particular section having a certain design or a certain structure, and you can override the base template to create a new base template, and that base template could be the base for all the other pages in that particular section. So the way I would like to look at it is, it forms a simple tree, though strictly it does not have to become a tree, and that's why I named this pattern as the template inheritance pattern. So this is quite simple to understand. You create a base template or a base HTML which has a lot of placeholders in it, and these placeholders are nothing but block statements, and these block statements could have some default values inside them. Now when you derive or extend from this base template, all you have to do is mention which blocks are you are going to override and what content needs to go into each of these things, and very simply you are getting the entire base structure for free, and all you have to do is customize what actual content goes into that. Another common template design pattern you see is the active link. So as you notice, in any menu or navigation bar, the user should not get lost. They need to know where they are at any point in time. So that particular location is actually highlighted. So here you can see that the user is in the home page because the home is highlighted. This is very easily done using an active class added to that particular link. But how do we implement this in Django? There are surprisingly a lot of ways to do this, including custom tags and all that. But a very simple way to do this just using templates is to use the include syntax. So you have something called the include and a snippet. So here nav underscore is the naming convention that some people use for snippets. Underscore navbar.html is there, and you just mention what active link is being used here. So here we are in the second link, so we call active link and set it to a value of link 2. And now the snippet is becoming very simple, right? All you have to do is you have a series of if statements which check whether that particular active link is set to a particular value. If it is set to that particular value, just use that link. Now, custom tags are also a good way of implementing this, but I find it much more easier to use this particular template only solution. So this is just, we are just barely scratched the surface, right? I mean, there are lots and lots of templates out, design patterns out there, and it's quite interesting to think about design patterns as something that you yourself can develop rather than something like a sacred set or a classic set of patterns that you should always follow. So my advice about patterns is it's very easy to overuse them, so I'd like to include how not to use patterns. So one thing is, you should not think that, you know, using a pattern makes me cooler, as some architects think, so I should just blindly apply template pattern, that singleton pattern, etc., etc. Just don't blindly apply the pattern. Every pattern comes with a problem statement, the context is very important. Next is, don't apply a pattern if your language supports a direct solution, right? So like I said, Python has a lot of features which are not there in certain other languages, or it's a dynamic typing language, so you don't really need to create classes just because a particular function accepts only a particular type of function, a particular type of class. There is no typing when it comes to what a function accepts. So just be loose about it. Just follow idiomatic Python or the Zen of Python. Third thing is, don't try to retrofit everything in terms of patterns, as I just said. And finally, don't be afraid to create new patterns. Patterns are something that you should share, something that you should create. Finally, I'd like to say that design patterns are not visible to end users, like I said in the beginning of the talk, but it is something that you will be always worried about, or something that you will actually try to seek actively. And don't try to learn patterns the hard way, right? So most people try to break their head until they figure out what is the best solution. And this is actually the worst thing that can happen to you. Try to study what existing design patterns are, and your implementation automatically becomes better. In fact, I found that when I read someone's code and I find that some pattern has been elegantly implemented, I can actually say that that guy is an experienced developer, right? I mean, he's actually gone through a lot of struggle to actually reach this point where he actually implements or understands that particular design pattern. So try to learn more about it, try to understand what patterns are, and soon you'll be finding yourself looking at patterns everywhere, discovering patterns and understanding them and creating more beautiful and elegant code. And ultimately it leads to a successful open source project as well, like Django uses all these design patterns to create a much more readable and elegant code. So that's all I had. Questions? Thank you. I think one of the volunteers would come to you. Just raise your hands if you have a question.
Questions? So if you guys are at the back, you can come to the mic there, or someone from this row I could possibly...
Yeah, there's a mic over there as well.
My name is Sanjay. Just a quick question around the user profile thing. I just want to understand, now that we can do the extend custom user profiles, just the reasoning behind not putting relationship status in, like why would you still create a separate user profile model? Can you just explain the reasoning behind it? I know you said, oh, it's not recommended, but can you explain why?
Yeah, it's basically to do with separation of concerns, right? So I think everyone actually, when they start their Django project, has the user profile built in, right? I mean, the user built in. It comes free with Django. But what is the purpose of a user model? The purpose is purely authentication. It's just to ensure that that particular user has the bare necessary details, just to ensure that that person can log in to that site, or use an authentication mechanism to get into that site. Now, this is of course a stylistic advice. If you find that there is more than one line necessary to describe what a model does, then probably you're doing a lot inside that model. So when you say that a user model is being used for authentication and user profile and something else, it means that probably you should think about refactoring that particular model into more separation of concerns. So user profile pattern is basically to separate that neatly. In case you have anything that is related to a user's profile, you just have to climb from request to request.user to profile, or something that is in the user context. Basically a design advice.
Okay, fair enough. Thanks.
Hi, my name is Rajkumar. I'm from mechanical engineering, so I'm completely out of all these fields, but I started Django last year when I got interested on the web application design. So when I get into this template design that is implemented in Django, is it something that I should consider libraries like Jinja 2 as a design pattern for the Django template, or how should I see these two things? Because people online, whatever I see, they talk bad about Django template and they recommend Jinja 2. So how should I see this?
Yeah, Jinja 2 is not a pattern, so to speak. It's a different implementation of a templating language, and the reason why people talk bad about it is the Django template language, which comes built in with Django, has some performance issues. Performance issues in the sense it becomes almost a 1:2 comparison when you talk about Jinja. And another reason is because it's a very strict templating language. It does not allow you to include Python code in it. So any kind of logic or any kind of Python programming you cannot do inside templates by design. It's very intentionally kept out of the templating language. So a very common thing which people find comfortable to do is put all that business logic into templates. So only when you come to that point, which still I do not agree with personally, I feel that templates should not have any kind of programming or logic inside it. It's only when you come to these two reasons, like performance and programming allowed inside templates, that you can replace it. And again, replacing it with Jinja is very easy. You can probably use Django Jinja package or any third-party implementation. It's very easy to replace it also. So it's only for these two reasons, not necessarily for any functionality or business logic related.
Okay, does this performance come with the concurrent users?
No, it's nothing to do with that. It's mainly, something like the way it is compiled. It's almost like running pure Python. So Jinja converts it into nearly pure Python, while the implementation of Django templates is something similar to regular expressions. So it's a slight speed up because you are running pure Python code in Jinja. That's all. Okay.
Thank you.
So we are a bit short in time, so you can catch him later. Okay. So thank you, Arun.
Thank you.
Thank you for
Thank you, everyone.
Can we have a